Hi everyone, thanks for watching class 25 of the topic how to rotate about accurate pivot point in UE4 C++. Let's open the project named Robot Tutorial 1. Today, we'll handle the program robot pose of robot rotation.cpp. Let's open File, open Video Studio. Robot rotation.cpp. Let's handle the join number 1 first. Move/start. To here. So we can handle the join number 1. The join number 1 is handle MSZ, moving up and down, which is a linear movement. Let's check the upper limit and the lower limit first. Look, the CSV table of CMS CAPP MS new 0601 file. The first limitation, 1 plus 3 makes 4, is upper limit 200 millimeter, is 20 centimeter. The lower limit is minus 20 centimeter. So the program written if bracket rj1 greater or equal 20.0 f bracket rj1 equal to 20.0 f semicolon, else if bracket rj1 lower or equal minus 20.0 f bracket rj1 equal to minus 20.0 f semicolon. And doing a translation, we use set relative location. And the program written like this, B2 minus greater set relative location bracket f vector bracket the x value 0.0 f, the y value 0.0 f, as to the z value is current position rj1. Okay, let's see by using rj1 plus equal 0.1 f semicolon. This 0.1 is centimeter. For every frames, rj1 plus 0.1 centimeters. Control Shift B compiler. In this topic, we must handle about the rest 4 axes, which are rotating operation. We have to take care about 3 pivot points. The majority one is x 149.32624 centimeter. The y 0, the z minus 77.89576 centimeter. This one, including MSH, MSZ, MSS1, MSS2, MST, and the second one is RGB arrow located at the 000 position. The third one only belong to MSB or RG, the parts rotating about x-axis. The pivot point is located at x 11.676555 centimeter. The y 0, the z minus 15.17709 centimeter. The last one is a little difficult to handle. Okay, compiling success. Let's see the program correct, okay or not. Back to UE4. The first axis is moving up and down. The upper limit is 20 centimeters. The program written. Testing, move up. So play. You see, moving up until 20 centimeters stopped. Okay, the program is correct. Then, for the second one, MSS1, the pivot point located at here. Since the original point at this point is the intersection between the C component's center axis, rotating center axis, with the center axis of A component's rotating axis. These two center axes intersected at these points. As to the first pivots located about somewhere here is from here to here, the x distance 149, y 0, z minus 77. Okay, now let's handle the second axis rotating and watching around these points, the pivot points. Okay, let's move /start down to this place in front of join number equal to 3. Okay, first let's check the second axis upper and lower limit. 8. Object 8. The transrotate 5. 5 minus 3 makes 2. So this is the second axis rotating limitation. The upper limit is 90 degrees. The lower limit is minus 90 degrees. So the program written if bracket rj2 greater or equal to 90.0 f bracket rj2 equal to 90.0 f semicolon, else if bracket rj2 lower or equal to minus 90.0 f bracket rj2 equal to minus 90.0 f semicolon. RB3 minus greater set relative rotation bracket f rotator bracket. The second axis rotating about z about the z positive direction, which is the yaw. The yaw located at the center. So the pitch feeding 0.0 f rj2 located at the yaw position, rotating about z positive direction. We tested before class. If we try to keep the right hand rule, we have to add a minus sign in front of rj2. That means change the rotating direction up and down. Since we add a minus here, so we have to add a minus here as well. And this safe variable, no need. As we are handling the YRAD2. Since the second axis rotating about the Z axis, so in here we have to change to ZRAD2. All of them has to be altered ZRAD2. We handle this first. Okay, done. After check the upper and the lower limit, next we want to change the pivot point according to the CSV table of CMS CAPP. For the second axis, the S pivot minus 115 centimeter. So in here, pivot location dot x equal to minus 115.0. The y is 0. The z is 53.06. F semicolon. As to the RZ matrix operation, RZ means the Z value is 0. The RZ matrix operation only xj2 and yj2 are influenced, and according to check RZ matrix operation from the CAD textbook, we write down rj2 equal to minus pivot location dot x multiply cosine bracket ZRAD2 bracket plus pivot location dot y multiply sine bracket ZR82 bracket plus pivot location dot x semicolon yj2 equal to minus pivot location dot x multiply sine bracket ZR82 bracket minus pivot location dot y multiply cosine bracket ZR82 bracket and plus pivot location dot y and then RB3 minus greater set a relative location F vector bracket Sj2 Yj2 Zj2 the same like previous rotation, then location. But location we have to adjust the pivot point to the correct position. Right now, we'll handle the first correction about the first pivot point located in the center around somewhere in here. The pivot point here, but why we have to handle about this one? Because the 0, 0, 0 position at here, from here to here, from here to here, the actually pivot points from here to here is the x distance is only short about 34 centimeter. Remember, previous we handle the rotation, then location. The pivot points always located at 0, 0, 0 position. Right now, it's different. But the arm is of x is only this distance. So in here, we have to do a modification about the pivot location dot x because the MZ matrix operation only handle x and the y. The y is 0. No need handle anything. So the only thing we have to handle the correction is about x. We have to add the influence of the first pivot point. Okay, how to write the correction? We have to add the minus 1, 4, 9, point 3, 2, 6, 2, 4, F, and then minus bracket minus 115.0 F bracket semicolon. After this correction, the arm between this here to here is only about 34 minus 34. Okay, let's compare to test the second rotation. Then we remove RJ1 and open RJ2. Control Shift B to see the results. Okay, success. Right now, rotating positive direction. As we play, we hope this arm rotating positive direction, rotating around here, moving and moving until to the 90 degrees, the upper limit, and stop there. We have to see if the pivot point in here, according to -149 corrections, will get moving correctly. Okay, play. Let's see. It's rotating positive direction, no problem. And let's see. These pivot points fixed or not. It seems fixed firmly. And let it rotate until to the upper limit, 90 degrees. To see the full process of testing. We wait at here to see the 90. Okay, stopped. Good. Now, let's handle MSS2. The join here, the pivot point here. Okay, let's move the slash start down to here. Check RJ3 upper limit and lower limit first. In here, we have to say this rotating about the z-axis, this rotating about the z-axis as well as to see rotating about the z-axis as well. So these three all are z operations. Okay. Check these upper limit, lower limits. That's to see 3 plus 3 makes 6. So the upper limit 150 degree, the lower limit minus 150 degree. So if bracket RJ3 greater or equal to 153.0, bracket RJ3 equal to 153.0 F semicolon. Else if bracket RJ3 lower or equal to minus 153.0 F bracket RJ3 equal to minus 153.0 F semicolon. Okay, since these two are the same, we use copy to handle it. B4, set relative location. F rotator 0.0 F. Minus RJ3, comma, 0.0 F, semicolon, semicolon, bracket. So this is minus, we have to add a minus sign in front of RJ3 and rotating about the Z, so we have to change the Y to Z, all of them. And let's handle the pivot points according to the CSV table first. RJ3, 3. So S pivot minus 50. Point 0 F, Y equal to 0.0. And Z 49.956. F semicolon. Okay, as to the MZ matrix operation, we can reference RJ2. So ZJ3 equal to 0.0 F. RJ3 minus pivot location X dot X multiply cosine bracket ZR83 bracket plus pivot location dot Y multiply sine bracket ZR83 bracket plus pivot location dot X semicolon. And YJ3 equal to minus pivot location dot X multiply sine ZR83 bracket minus pivot location dot Y multiply cosine ZR83 bracket plus pivot location dot Y. And the same, we don't forget the correction of pivot location dot X. Copy this one and add in front of minus 50, and with a bracket here and a bracket here. Okay, RJ3, let's use double slash, remove RJ2, and remove this double slash of RJ3, and rotating faster, 0.1 degrees for increasing for every flange. Control Shift B to see the MSS2 components rotating about its pivot points, correct or not. Okay, let's see what's happened. Put a cursor down here, double click by the right hand. You will see the mark here. Get arrows. One is here and the other is here. This one should be common, not a semicolon. Okay, this red symbol removed as well. So Control Shift B, compile. Let's see we're rotating about the positive direction. Success. Back to UE4. So the positive direction, this one, we are rotating this direction. And this pivot point fixed, no move, and rotating until 150 degrees before the model touch the side surface of MSS1. This arm will stop. Okay, play. Rotating direction, positive direction is correct. And the pivot points in here of MSS2 seems okay. And rotating until this one to 150 degrees. The program to the upper limit stopped here. So the program altered correctly. Now, next, we'll handle the CMSC ORG. The same MSC ORG rotating about Z-axis as well. Let's move /start down here. Check the upper limit, lower limit first. This is the C-axis. In the CSV table, the 5-axis and the 4-axis upside down. The Z is 5-axis, but in here we are 4-axis. But no problems. We check the 5 upper limit. The 5 plus 3 makes 8. 540 is upper limit of the MSC ORG, minus 540 is the lower limit of MSC ORG object. So in here, if bracket RJ4 greater or equal 540 F bracket RJ4 equal to 540.0 F semicolon, else if bracket RJ4 lower or equal to minus 540 F bracket RJ4 equal to minus 540.0 F semicolon. This one, we remove it. Since the same like before, we just check. RJ4 should be in the center and change the sign to the right hand rule. Okay, then minus RJ4. So in here we have to add minus RJ4 since rotating about the Z-axis. So this one should be ZRAD4. And let's check the pivot point first. The pivot point for MSC is 0034.606. So the X is 0. F semicolon. Y 0. As to the Z is 34.606 34.606. Okay, the MZ matrix operation. Let's copy from here. This one, remove first. MZ operation ZJ4 equal to 0.0f semicolon. Only SJ4 and YJ4 are influent. So SJ4 equal to minus pivot location dot x. Multiply cosine bracket ZRAD4 bracket plus pivot location dot y multiply sine bracket ZRAD4 bracket plus pivot location dot x semicolon. YJ4 equal to minus pivot location dot x. Multiply sine bracket ZRAD3 bracket minus pivot location dot y multiply cosine ZRAD4 plus pivot location dot y, and at the last RBO5 set relative location f vector SJ4 comma YJ4 comma ZJ4 bracket semicolon. But don't forget, we have to do the alteration of the first pivot point of x. Minus 149.3264 f minus the original value, the 0. Okay, then RJ4 remove RJ3. Since RJ4 rotating, the lower limit 540 degrees. How about let's let it rotate faster for each flange with 1 degrees difference. Okay, Control Shift B. Now testing the MSC ORG rotating minus direction. Success. So the minus direction means rotating around like this. And we check the rotating direction. We check the pivot point. And we check the end limit minus 540 degrees. Okay, play. No rotation. Okay, let's see Where is the wrong place? Oh, this one we didn't remove. Okay, Control Shift B, recompiler. We don't need use extra instructions for changing the sign of RJ4. Okay, let's play. Right? You see rotating direction. Okay. And the pivot points fixed in here, no problems. And 1.5 turns to the lower limits, 540 degrees. The rotating stopped. So correct. Now, for the last axis, the chopper one, let's remove /start and back to here. Check the lower limit and upper limit first. The limits 4 axis in here, 4 plus 3 makes 7. So the upper limit of MSBORG is 90 degrees. The lower limit is minus 90 degrees. So the program written like if bracket RJ5 greater or equal to 90.0F bracket RJ5 equal to minus equal to 90.0F semicolon. Else if bracket RJ5 lower or equal to minus 90.0F bracket RJ5 equal to minus 90.0F. Now RJ5 is rotating about the x-axis. The x-axis is roll. We should place RJ5 at a low position. Actually, at the third position, the lower position is here. And according our understanding, we need a minus to change the system to the right-hand rule, RJ5. After rotating, we have to do set relative location. This with minus. So in here, we have to add a minus sign in front of RJ5. And this is rotating about the x-axis. So this one should be XRAD5. All of them has to be altered. And the MX operation, the SJ5 equal to 0.0F. Only Y and Z are influenced by the MX operation. We can find the equation from previous lecture to find the MX operation equations. So yj5 equal to minus pivot location dot y multiply cosine bracket xrad5 bracket minus pivot location dot z multiply sine bracket xrad5 bracket plus pivot location dot y semicolon zj5 equal to pivot location dot y multiply sine bracket srad5 bracket minus pivot location dot z multiply cosine bracket xrad5 bracket plus pivot location dot z semicolon and RB6 minus greater set a relative location bracket f vector bracket sj5 comma yj5 comma zj5 bracket semicolon, and then we have to handle the last one about the pivot point of MSB-ORG component. 3 pivot points have influence about these elements. The better way is to handle the first and the third pivot points. The adjustment not in here, only in here. So we can simplify the rotating pivot points in here. Okay, how to do the alteration? Relate the translation of x minus 149.32 624f plus the third pivot point 11.676555 f, and then plus sj5. The yj5 0 no influence in here, and then comma the z, the first z pivot point 77.89 57 6 f minus 15.17709 f, and then plus zj5. So relate the first pivot of x, the third pivot of x plus sj5, the first pivot of z, the third pivot point of z plus zj5. After this correction, the pivot point of MSB we can see here from the button of MSB-ORG to the rotating center is 15.17709F. So a pivot point shift to here. In the program written in here, the X 0.0F, the pivot location, Y 0.0F, as to the Z, lift up from the third pivot location up 15.17709 F. Okay. Then remove this double slash RJ5 minus equal 0.3 F semicolon, and there isn't RJ6. So Control Shift B to compile and test the last one. MSB ORG rotating minus direction. Success. So what we expect to see? Minus direction. The positive direction rotating this direction. The minus direction will rotate it this way. Okay, let's see. The rotating direction and see the pivot point, and then the last state at 90 degrees. 3, we have to watch it. Okay, rotate. The rotating direction, no problems. The end to minus 90 degrees, no problems. And how about the pivot points? Fixed firmly in these positions. So the program is okay. As to the rest, the tool as well as RGB errors, we wait for next video. Thanks for watching. I will see you next time. Bye bye.